Hello, thank you for joining TPM's 2024 rendition of What's New in SOLIDWORKS. In this session, we will discuss SOLIDWORKS automation using DriveWorks. In doing so, we'll introduce DriveWorks. What is it as a software application? What does it do? Furthermore, why should you consider design automation? Then we'll dig into what the essentials of design automation is all about. And finally, we'll wrap up with a demo showing DriveWorks in practice and give you an intro to what a day in the life of using DriveWorks is all about. I should mention, if you want to learn more about DriveWorks, automating SOLIDWORKS, or anything similar, please be in touch at support@tpm.com. So, a few things about DriveWorks. DriveWorks is an independently owned business that's been going for over 20 years, with a long legacy of all things SOLIDWORKS automation. There's a long-standing relationship with SOLIDWORKS, being a preeminent gold partner specifically for CAD automation. DriveWorks can be used as an add-in within SOLIDWORKS and or externally as a separate application. DriveWorks is known for three main functional, what we call pillars. First, and what we will dig into today, is all things SOLIDWORKS automation. But additionally, it's capable of building out a CPQ system. It's otherwise known as an online configurator, and it can be used as an integration platform to help bring all of your various business systems together, which is particularly helpful if you have a SOLIDWORKS-based tech stack. DriveWorks offers three products that together form various points of entry to get into automation. First, there's DriveWorks Express, which is included in every seat of SOLIDWORKS and is free. This is a great way for those who are automation curious to dip their toe in the water and see what it's all about. Next step up, DriveWorks Solo, which features a 30-day free trial and is a great option for intermediate needs for automation. Finally, there's DriveWorks Pro, which is an enterprise-grade offering that offers unparalleled automation capabilities, integration capabilities, in addition to being the platform for online configurators. The demo we'll show later was made with DriveWorks Pro. Now let's discuss why manufacturers are considering automation, starting by addressing the topic at the business level. Virtually all of our manufacturing clients tell us they're simply too busy. They need to figure out how to do more. Time, both in terms of valuable personnel time and upholding competitive schedules, it's a serious bottleneck that demands a solution. So when we look at where the time tends to go and assess what value that use of time presents, these are the typical responses we get. Well, we only win the minority of the business we quote, but we have to pour in valuable engineering resources all the way. Really, it's a waste of time. Let's say we only win 20% of our quotes. Well, that means 80% of our time was wasted. Or let's say between complicated product and the needs of the factory, we have to supply countless drawings and other documentation. This can take days, if not weeks, to get the production packet ready. Really, when we look at it, we're just copying information from one place to another, from one system to another, just to make it understandable for someone else. Another example, one mistake in a BOM entry or a drawing error can cost thousands of dollars and create huge delays. When you think about it, it's frightening how a simple human error can cause disastrous effects. You spend a lot of time double checking, triple checking to make sure this doesn't happen, and sometimes it still does. Finally, what's the result of pace of business being directly tied to the pace of personnel activity? What's really clear in today's job market is that qualified personnel is becoming harder and harder to find and retain. Simply put, how will your business grow if it's held back by your current staff's capacity? So let's move on to why automation at the product level. First, think about your product and where it may be on what at TPM we call the configurability spectrum. There's a wide range here, so let's break it down to help characterize the nature of configurability. What we want to be able to answer is, how does the nature of product configurations challenge a business, and what are the opportunities to seize with automation? Starting at one extreme is widgets. Best example, say, is an injection molding firm that pumps out parts by the thousands. Their designs don't change, and one day after another is just a repeat. On the other extreme is the truly one-off, and we're specific with that term. One-off means the deliverable product and all the work required to fulfill it is definitively unique every time. The definition of unique is that from one day to another, little to no insights or data or design content can be carried from one experience to the next. I will say, at the extremes, the value of automating SOLIDWORKS activity can be tough to establish. But for anything in between, the prospects are much improved. Now notice we do include catalog and custom products within this serviceable part of the spectrum. The notion of a catalog-based product, I'll circle back to that later on in the demo by example. Custom is interesting because we often challenge a client's definition of what custom means. Clients might think of themselves as operating in a custom environment, but after further discussion, we conclude, from an automation standpoint at least, that they really are not. That's the result of asking our first key question, which is the way you conduct business based on years of experience and history, established policies and procedures, in such a way that today is some variation of a prior day. For example, when an engineer, designer, drafter sits down to create content in SOLIDWORKS, is he acting randomly or at will in the moment? Or actually, is he working against rules, formulas, some kind of know-how in a bit of company sense, common sense, all the way? If the answer is yes, it is truly random or extremely different, then that'll be in the one-off territory. If not, then ultimately, we're in a conversation about configurability. Furthermore, think about the effects of configurability on your organization. Are all the product options a challenge for sales to stay on top of? Is it quite possible your product can be sold in some kind of an invalid or unexecutable state? Managing configurations means managing a lot of data, not just in design, but ERP, purchasing, and managing the factory, all the way through to shipping. Configurability compounds the complexity of managing the activity within the business in nearly every department. Finally, and more specifically, how does configurability affect the engineering department? Take a step back and observe the time spent exercising the department's workflows. Is there an overwhelming proportion of just busy work? Work that simply boils down to, let's say, copy, paste, modify, or entering the same piece of information multiple times in various systems. Stuff like that we would consider busy work. Really, ask yourself, is the activity that you would like to associate with the practice of engineering or design in play, or are most folks just shuffling around information? This brings us to the final layer of the CAD automation onion, which is studying the practices within the engineering department. For most watching, this will be the good stuff. A thorough study needs to start with identifying the where. Where is the intelligence that underpins the entire process of successfully designing your product? Establish the landscape of where, and you will generate a list of points, at least a few of which will be in the following areas. Most often, design intelligence can be found in SOLIDWORKS. This is a natural starting point. But a close second is Excel. Why Excel? Well, everyone has it. It can be handy to dump insights into and save for future use. What is often not recognized as much as it should be is how much design intelligence is captured, well, frankly, nowhere. Not on paper, not in a file, stashed away on your desktop, or some old Xeroxed piece of paper that you reference from time to time and stuff in your drawer. Nope, it's just floating around the company's ether, simply accepted as the virtues of veteran experience and tribal knowledge. Simply, somehow people just know what to do. Then there are companies that have taken the step of attempting to institutionalize the design process, somehow with a third-party application or some form of custom coding. Doing so is a noble effort. However, we can't ignore the perils that we hear from our client base. The realization that they are a manufacturing company and not a software company starts to ring loud and true when they find themselves in a position that they can't access said code or even to know what to do with it if they could. Ultimately, clients find themselves unable to maintain these solutions over time and are effectively stuck in the past. All right, well, let's circle back to SOLIDWORKS because there's a lot to talk about there. As we all know, SOLIDWORKS is a wonderful CAD package filled with all sorts of time-saving and user-friendly tools. We've outlined here the top ways to use SOLIDWORKS to help save time in the context of managing a configurable product. If you're watching this now, I'm sure you're familiar with all of them. You've probably put a lot of them to use in your workflows today. There's the old save as, copy paste, and the more formal pack and go for the sake of recycling prior work content. This has its perils, but it's definitely better than starting from scratch. Configurations, design tables, variables, and the nature of parametric design are good first steps in capturing, standardizing, and attempting to institutionalize how your product is physically variable. While these are indeed great tools, we have seen how, when taken to an extreme or used to tackle more sophisticated challenges, the tools can reach a limit and even break down. Sometimes they create more confusion than they were intended to prevent. The good news, however, is that if you put effort into these kinds of tools, you're already a few steps ahead in what it takes to truly automate. We'll circle back to that more later, shortly. Top-down or in-context modeling is a savvy technique that builds relationships across an assembly. This is a nice time saver and error prevention technique because design elements can enjoy a one-to-many relationship that avoids repetitive data throughout the model data set. The one inherently limiting downside of these relationships, however, is that they are explicit dependencies that are established on presumptions or knowledge that may not be suitable for recycling later. Top-down models can quickly implode if the dependencies are not honored, which also yields a scenario in which confusion can outweigh the intended benefits. Finally, we all have a collection of macros in our SOLIDWORKS taskbar, either made by yourselves or perhaps provisioned at a corporate level. Macros can be handy. Just click once and save a series, sometimes a meaningful series of button clicks. No doubt, macros are an expression of automation, but they're almost always a point solution to a point problem. You will soon see that this is nothing close to true and complete workflow automation. Also, you can't forget that they are rooted in code and do require maintenance over time to remain functional. So, where does this leave your engineering department, or even your organization as a whole? How would you characterize how business is conducted, and what goes into any given workflow or process? Is a workday filled with manual and tedious busy work, whose main accomplishment is moving the same information from one place to another? By virtue of relying on human activity in various business systems, is there a significant chance of error? Are there non-human controls in place, or does it feel like it's just the Wild West to get things done? What about how information is gathered, shared, and retrieved later? Does it feel safe? Is it robust? Is it easy to access? Can you point to a single source of truth for any given piece of information? Finally, what does making progress look like? Is it in your hands, or is it abstracted away out of reach? Take a step back and look at the total experience. Do you identify more with playing a game of whack-a-mole or making real valuable improvements for your department and your business? We've established the whys behind automation, so let's move on to the what. What is design automation and what does it take to pull it off? There are three main concepts to understand design automation. The first is the notion of design intent, and it relates directly to the topic of design intelligence we discussed a few moments ago. But does this intent exist? The answer is usually yes. It's just a matter of where. As we saw, it can be in any number of places, whether it be physical, digital, or sometimes literally nowhere. When we say design intent needs to be created, this is usually an exercise in collecting it. Identify what the content is, capture it, run around the office with a net if you have to, and position it in some kind of observable form. It can be a collection of papers, files, notes, flow diagram, or just post-it notes on the wall. To get started, it doesn't matter yet. Just put it all in one place, out on the same proverbial table or in the same proverbial bucket. Doing so, form will be what will be the early makings of the single source of truth for all things design that your future automation system will be built on. With all this intent created, now it's time to institutionalize it. This is key. It needs to go beyond just being present. It needs to be actionable. Actionable means comprehensively synthesizing concepts like rules, logic, and process to a single intentional and complete sequence of activity. Sounds great, you might say, but how do I go about doing that? At this precise moment is where DriveWorks enters the conversation and literally changes the game. Now, this content is better seen than described, so I'll save the majority of the explanation for the demo. But in short, DriveWorks is not just a single source of truth for content, but for all the associated know-how that goes with it. It is a place where programmatic and algorithmic approach is conceived and executed. There are a number of user-friendly and accessible logic creation tools that DriveWorks is built on. More on this in a few minutes. With all that design intent established and ready for action, the next typical step in automation is to create a process. That sounds a bit fuzzy. You can think of it as a form, a place where a user, such as an engineer or drafter, or perhaps even a salesperson, wink, wink, can be walked through a series of questions, thereby successfully specifying your product. We have a simple example of a form here. This one has, as you can see, 6 main pages, each of which have subsections, partitions, and subareas and the like that intuitively organize the line of questioning to the user. You can see various ways to ask questions, such as with checkboxes, drop-down menus, interacting with tables, or even just simply entering values by hand. Furthermore, on the far right is 3D imagery that gives real-time visual feedback to the user to help confirm the validity of their selections. After all, if a picture is worth, 1,000 words, then a 3D image must be worth, a billion words, right? Well, that might be an overstatement, but it does illustrate how a well-formed process can make all the difference in the world in terms of solving some of those stickier problems we spoke about earlier. If your business is plagued by a lack of controls or process, then these topics are extremely important. Furthermore, in DriveWorks, forms are made to be intelligent. In real time, we validate the user's entries, check that there are no conflicts with prior entries, and otherwise help the user navigate what can sometimes be a sophisticated line of questioning. When you think about your design process, is it a nice and tidy and linear thing, just simply asking one question after another? Probably not. It might be more like a decision tree, and perhaps a really tall and wide one at that. Even worse, it might be more like a spider's web, in which every option is somehow connected to all the rest, and possibly even in some kind of circular fashion. How do we make sense of that? We won't be able to convey it all today, but let it be a takeaway that these are the challenges that DriveWorks was built to solve. So with that design intent in place and a mechanism to make it relatable to a user, what's next? Actually, it's just the automation. When that request button is clicked in the form, that final step, DriveWorks automation just simply takes it from there. Instantly, DriveWorks processes all the logic based on the user's inputs and gets to work. That means that any and all SOLIDWORKS files are created, driven to their required specification, and put somewhere for future use. Parts, assemblies, drawings, and any of their derivatives thereof are in the mix. Simply, if you can do the picks and clicks in SOLIDWORKS by hand, then hit Save As. DriveWorks can do all that automatically, just much more quickly and making 0 errors along the way. And it's not just SOLIDWORKS files either, but Word, Excel, PowerPoint, CSV, XML, you name it, any kind of file type that you're used to working with is in play. Beyond that, sending emails, entering into a database, communication with other systems via web services, it doesn't matter. Virtually all activity you would associate with quoting, design, or production preparation is automated. Believe me, manufacturing companies of all types are achieving 100% lights out, hands off, automated engineering workflows with DriveWorks. Now, I will acknowledge that success like this is not achieved overnight. After all, automation is not magic, and those kinds of results are the fruits of a continuous improvement effort through which they have eventually chased every single manual task out of their process. It takes resolve to do so, but it is very possible. That's nice and all, but that's not actually the message for today. Rather, Just simply think about the prospects of eliminating even just a modest 25, 50% of your current workflow. What kind of impact would that have on your business? All right, enough of the PowerPoint. Let's see DriveWorks in action. Today's demo will feature a fictitious company, CSL, a manufacturer of scissor lifts. They've used DriveWorks to solve their CAD automation desires, but have extended that capability to become an online product configurator or CPQ tool as well. What I'm about to show you is all on my local machine, which, by the way, is just a typical laptop suitable for SOLIDWORKS purposes. I say this to indicate that DriveWorks does not require any special hardware to get started with automation. One can get started as a single user on a single machine that you already own. That being said, DriveWorks is a very scalable solution that can easily be grown into an enterprise setting, featuring many users in many locations, etc. I'll say again, this demo was built in DriveWorks Pro. However, very similar functional results are achievable with DriveWorks Solo, and frankly, you can get pretty far along the way with DriveWorks Express as well. Actually, this same demo is available for you to try at any time, among many others on the DriveWorks demo site, driveworkslive.com. Here you'll see how my demo today, which is focused on engineering and design matters, can be extended into other areas of the company like sales and marketing. These topics are for another time, but let it be known that's all part of the same software. As mentioned previously, this demo was made in DriveWorks Pro. The core application within the Pro suite is called Administrator. This is where a project is born, built out, all rules, logic, and activity come to life. But before we dig in and see what happens behind the scenes, let's take it for a spin and create a quote. In DriveWorks, we call this running a specification. And here we go, CSL's product configurator. Let's take a look at what there is to see. First, on the left is the main part of the user interface. That's the area where the users will enter information about the scissor lift they want. Just to the right of that is a textual summary of the product, just for reference. Then, in the bottom right, is other additional reference information, like real-time pricing, real-time bill of materials calculations, and even the quote representing the product in its current state. Note, this information will change as we continue to specify the product, all in real time. Then, in the middle, most obviously, is what we call 3D preview. You can think of 3D preview as an analog of what to expect as a SOLIDWORKS output. Now, what you're seeing right here is not SOLIDWORKS inside of DriveWorks, but DriveWorks' own rendering technology. Keep in mind that as we make changes to the design and 3D preview reacts accordingly, you could imagine how the SOLIDWORKS model will be driven in a few minutes. Let's start to make some changes and see what happens. We can change things like length and width and start to study what capacity means. Safe working load. What kind of changes does that entail? Oh, the label changes, but also underneath, we turn the model around, we can see how various aspects of this design change with every safe working load choice. Next, onto the platform type. Flatbed is basic, but we can progress to higher end designs. Roller bed, even a roller bed that rotates. Let's stick with the roller bed for now. Mostly because we could save $300 by skipping the rotator part. Purple's not great. I think I'll stick with black. All right, one more step to go. What we see here is something of a product code decoder. So the prior 4 steps, the user was asked to make one choice at a time, some kind of a logical manner, getting to the end of the road by finally specifying a color. But really, for CSL, all that did was led the user to the correct part number. They have a smart part numbering scheme, in which every aspect of it means something intelligent. It turns out that the first 4 steps may not have been required. If the user simply knew the part number, that could have been entered here, either by a salesperson, an engineer, or even the end customer. Final step, let's confirm who we are. In this demo, they're using a dummy database just to simulate being connected to a CRM system. Not necessary, but a nice touch. Finally, they want to know who we are. I'll go ahead and enter my name and email. Then we'll get to the automation. Now, you may have just noticed that it wasn't until I fulfilled my email address and had a valid email address, that field was no longer highlighted red, and then the submit button became available to click. That's just a basic form of data validation that can be included all throughout the process in the UI. So upon hitting submit, we're going to see what happens next. Here we see another application within the Pro Suite called Autopilot. Autopilot works very closely with SOLIDWORKS, effectively telling you what to do every step along the way. So once we hit the start button to start the service, more on that to come, we'll see that DriveWorks jumps into action, recognizing that a quote has been submitted. And after that, we'll see every single part, assembly, and drawing file that needs to be created. And here we go, one part at a time, being driven according to my exact specifications. Along the way, DriveWorks is telling SOLIDWORKS how to modify each file, whether it be driving a new dimension value, suppressing or unsuppressing a feature, driving advanced feature parameters, driving properties, you name it. If it's in a SOLIDWORKS file, DriveWorks can control it. As we go, let's see what kind of outputs there are. This project features file location, file name rules that tells DriveWorks where to put each individual file. In this case, they're all going into a single file just for this quote number 11. Drawings, part files, and all sorts of accessory content as well, such as quote documents, Excel files, Word files, images, and the like. Okay, so this job is done, and we can see that it took about 5.5 minutes to run all those files. So let's take a look at the final output. For most purposes, it's a PDF drawing. You can see there's drawings purpose for customer purposes, for manufacturing purposes, for sales purposes. So let's take a look at the final output and compare that to what we were expecting by using our form. Black roller top conveyor or scissor lift, looks pretty close. I think we got the output that we wanted. So let's study the final result in SOLIDWORKS. Here's the top level assembly. As you can see, it's a normal assembly, just as if an engineer had made it by hand. It's traditional modeling practices in place, capturing the CSL standards, whatever they may be. It's important to note that an automatically generated assembly and all the other content in SOLIDWORKS can be used downstream manually. So now that we've seen generally how DriveWorks works, let's study how this is all put together. While in SOLIDWORKS, we're going to open the DriveWorks pane embedded within the CAD software. You can see DriveWorks working right inside of SOLIDWORKS. This is simply done with an add-in. Once logged in, we can see the state of the project in the main pane. Here we can see what are known as captured files. These are the top level assembly plus a few what we will call replacement assemblies. Here I'm comparing the generated output to what we would call the master. Similar but different. Not just dimensions and colors, but we can see that the bed itself was swapped. We ended up with a roller assembly, but the master starts with just a basic flat table. Let's take a deeper look. Here's the flat table as captured in DriveWorks. But we also have another subassembly called the roller bed assembly that's been captured. DriveWorks knows about it, and it's ready to be replaced into future assembly as needed. So let's dig a little deeper into other aspects of control of the model. One area of moderate sophistication is controlling the roller spacing. Let's see how that was implicated using DriveWorks. So in the assembly, there's a pattern that controls such spacing. The dimension of the pattern, this is where you go to modify that manually. Actually, it's not the dimension rather, but the count. That's been captured with DriveWorks, as you can see on the top right. And it's not just the rollers themselves, but the holes as well, and several other features of this product all need to know about the roller count. Another design element is the width. So here we are in a subassembly that needs to react to the overall width of the product. In this case, the width is going to be controlled by mate. This mate is the simple distance mate. It has a dimension that's also been captured. Finally, let's dig down to a part level. This is one individual part of many that's also being controlled with a lot of detail. In this case, 3 aspects of this design are captured, all dimensions. Okay, let's see how the rules work. Here we are in Administrator, again, the development module of DriveWorks Pro. The first model we began to explore was the fact that the master assembly featured a flat bed as its default configuration. Studying that file in of itself, we can see a variety of rule types that are available to control. This one's what's known as the file name rule. This is a nice example because it has moderate logic to it. You can see in the rule builder here we have 2 if statements, one embedded inside the other. So if that particular condition is satisfied, then we're going to use what's called a replacement command to swap out that flat bed with the rotating bed. And if that's not the case, then we'll swap it in with a roller bed. And then if that's not the case, then we'll just stick with the bed that's in the master and give it a smart file name. In the rule drill down, we can see how all this logic rolls up and creates the desired result. So let's see this in action. We can go to our form, pick a different now, change in front of us, and is giving us the result requiring the roller bed instead of the flat bed. All the logic checks out. This is a good rule. Let's move on to the roller bed that will be the replacement model for the flat. Remember we studied the roller quantity aspect of the design? Let's dive into how that rule works. So here we have a variable called number of rollers. Let's study what that is. Well, turns out it's a number of roller gaps plus 1. But what's the roller gap mean? Well, a little bit more logic here. We have the bed length minus 40 divided by 45, and we're going to tidy that number up using the floor function. Just another example of how there's a variety of ways you can address logic in DriveWorks. Let's keep digging. Bed length leads to beam length plus 50. Beam length, oh, here's some more math. Do some Pythagorean theorem, round that off, and then add 25. Why? To be honest, I don't know. We'll have to ask their engineers. And we keep digging, and there's more and more logic. You might not be following along, but I think what we can see here is that in that decision tree type format of how this product works, we're getting pretty deep into the tree. But what we see at the end here is finally a connection back to the form. There's an aspect of the form called lifting height. Let's back our way out and go see where that is. Here we go. This looks familiar, called lift height. There's a range built in of 300 to 600. Let's max it out and see how the rule adjusts. Now it requires 18 rollers. At the minimum height of 300, the design only requires 10. All that logic seems to be working perfectly. Now let's go back to that single part that we checked out with the 3 rules. Same concept, we have the rule builder that might feature a variable, that features another variable. Therein contains all the logic. Now I recognize this beam length. I think we saw that before. To understand the concept of variable, Let's see where all the places in the project that this concept of beam length is put to work. So variables are a great way to create chunks of functionality and chunks of logic and then refer to it commonly throughout the implementation. It's a very efficient use of logic. We can see beam length is one of many other variables in this project. It's not just variables for designs, but file names, forms, other activity throughout. When we think back to talking about design intelligence and where that actually lives, in DriveWorks, oftentimes it lives in something like a variable. So let's expand all these models to see what the totality of content is for the single product. There's quite a bit here. Between all the part files, the sub-assemblies, and the assemblies, there's a lot of things to control. We're also seeing rules for drawings, both at the sheet level and the file level, and for their PDFs. As you can tell, the opportunity to control literally every detail of every single component is at your fingertips. When we add it all up, there are almost 1,000 rules to control this product. Earlier in the discussion, I mentioned that DriveWorks can also be run in SOLIDWORKS. Here we're going to go back to SOLIDWORKS and start a specification just like we did in Administrator, just to show that for engineers and designers, DriveWorks can be used in the native habitat of working within SOLIDWORKS. We'll fast forward to the last step just to show what happens next. In this case, instead of using Autopilot to automatically generate the files, the user has the option to choose which file to run and when, and trigger that manually. Here we selected the top level assembly, but we could also cherry pick any given individual file as needed. And just like that, the automation carries on right in front of you. So that's an example of consuming DriveWorks through SOLIDWORKS, but DriveWorks can also be consumed through a web browser. The browser can be public, a public website, or it could be an internal site. That's up to you. This site is driveworkslive.com. I mentioned this address a few minutes ago. This is the public-facing demo site that DriveWorks has put together to explain everything about DriveWorks. This is an example of what's called an embedded configurator, right into a website, live, real time. Can't even tell that there's DriveWorks behind the scenes. Further down, see an array of industry examples covering just about every product you can imagine. There's the scissor lift, which we'll circle back to in a minute. At the bottom, I'd like to point out DriveWorks' review of its own tech stack. There's even one about automating CAD. A lot of the concepts that we went over today are very nicely explained in this demo. What's interesting to think about is DriveWorks is using DriveWorks to demo DriveWorks. You can click through the UI, take a quick lesson in what automating CAD is all about from the words of DriveWorks. Okay, back to the scissor lift demo we go. We're going to run through this quickly just to show you one example of how DriveWorks can be set up. I'm going to fast forward to the last step and see what happens. Here we can see into the back end of DriveWorks' own servers, which is essentially conducting the same activity that I showed you on my laptop. This gives you a good overview of all that goes into automating this product. DriveWorks is in real time going to calculate all the needs and all the deliverables right here on the site. Give it a few minutes and we'll see the models, drawings, documents add up. Already, the BOM's available, as is the quote. And in real time, DriveWorks is still calculating. So far, it's come up with 42 specific items that it needs to produce. In the meantime, let's talk about what's going on from an installation standpoint. As we saw before, Administrator is the application where all the development occurs. Then there's Autopilot, which does the actual automating. That typically sits on what we consider simply called the machine in the corner. That could be a spare workstation that your company has, in a server, even in the cloud. Doesn't really matter where. It's just a dedicated machine with DriveWorks Autopilot and SOLIDWORKS working together to produce the content. Finally, there's DriveWorks Live. That's what enables DriveWorks to be available on a website like you see here. Back to the dashboard, and the job is complete. 100% results, and now we see there are 82 total documents. Remember those PNG files I referred to? Here, they've come in handy, showing the user in real time on a website what content has just been created. You scroll down, and we can get access to all those files and download them if required. And there you have it. That's an introduction to automating SOLIDWORKS with DriveWorks. Hope you found this informative, and you'll consider this for your business. Again, find out more by reaching out at support@tpm.com.